Okay, we're group number 12, formed by Alex Mateo, Vega, Maric Plaño. We're going to present our project up next. First is the description of the problem. We did an in-depth analysis about the fabrication of boxes, and we saw an issue in the corrugated cardboard production due to delays in manually transferring between the corrugation and printer stages. This is done manually nowadays, and we depend on the experience and fatigue of the workers, giving us a delay of operation. All this information was obtained by the engineer Steven Martillo Granado, that was our contact. The justification is that the goal of Cartorama is to make boxes of any size that we can use to put products. To achieve this in a better quality, we need the application of flexible manufacturing system and automation in some stages for the box creation, improving our capacity production or time production and reducing the cost of boxes. Next, we have our objectives that are to observe and improve the flexibility of the manufacturing process of creating boxes to optimize the production and get better results in Cartorama. Find a solution to the problem of the system by implementing a layout of flexible manufacturing system to be more efficient and minimize production waste. Formulate structural framework that optimizes material efficiency, installation of conveyors combined with different methods to move the material between stages, to make the prototype obtain a rentability factor around 25%, implementation of robotic arm to help the process between stages.
Hi, I'm Alex Mata, and I will talk about the high-resolution prototype. So, to create a high-resolution prototype of our proposed solution, we employ the software FlexSim. As can be seen in the simulation, we position each of the machines that make up the plant. This includes the corrugator, the conveyors, the robotic arm, the printing presses, the strapping machine, the palletizer, and the final rack. And we also include the operators who will work on these machines. Our project focuses on the optimization of the transfer time of cardboard sheets from the corrugator to the presses. To accurately simulate these processes, we consider that the corrugator on the plant produces 30 meters of corrugated cardboard per minute. Given that we are working with 1 meter long sheets, the processing time will be 2 seconds for each of these sheets. Furthermore, we know that the setup time for these machines follow a normal distribution with a mean time of 10 minutes and a standard deviation of 2 minutes. For each of the printing presses, we took into consideration that the ones available in the plant are wired and have an approximate production rate of 20,000 boxes per hour, and the plant will operate for 12 hours a day. And as we can see in the final rack, we produce 6,720 boxes per day. This information is the setup information for the simulation, and we can see that in the palletizer that we have the 6,720 boxes that we produce in a day. Moving on the financial analysis of the project, we base it on the client's earnings from the past year, which exceed $26 million. Additionally, we consider that we will only work with the largest sheet size, which has the following data. The annual boxes demand is 1,665,099 units. The price is $2.75. The annual labor day is 273 days. The labor shift is 12 hours per day, and the daily production that we have to reach to satisfy the demand is 6,102 units per day. We then proceed to calculate the cost associated with the equipment needed for the project's implementation, which include a robotic arm, a QR code scanner, and the conveyors, and has a price that we can see in the following pictures. Using this information, we generated a cash flow analysis. In year 0, the costs include the equipment investment of $41,500 and an initial company setup cost of $1.5 million. For the first year of operation, the company will earn a profit of $575,000. However, a return on the initial investment is not achieved yet, as there is still a deficit of $975,000. In the second year, the profit will increase to $626,000, and the deficit will decrease to $339,000 in this year. By the third year, a profit of $827,000 will be realized, recouping the initial investment and generating an additional profit of $477,000. Finally, the fourth year will yield profits of around $1.1 million, surpassing the investment amount by approximately $1.6 million. The analysis also included the calculation of the internal rate of return, IRR, for each year's cash flow. Considering that the client stipulated a project feasibility if a minimum return of 20% is achieved, the calculated IRR is 31.8%. Furthermore, the net present value is approximately $1.9 million. Exceeding the payback period was also calculated as 1.93 years, indicating a return on investment in about 2 years, which aligns with the cash flow analysis. In the lower section, we can see various categories of costs, both direct and indirect, fixed and variable, that were considered when conducting the cash flow analysis. Thank you.
Hi, I'm Maric Plaño, and these are the conclusions. First, a flexible system was accomplished in the stage display by adding a new transport between them of an automated conveyor, making more efficient the process by adding a robotic arm to be used to scan the labels of boxes. Then, with the economic analysis, showed the acquisition of the automated conveyor and robotic arm will be profitable for the company, increasing productivity and flexibility over a long period of time. Then, with the high-resolution prototype in the software FlexSim, there is an improvement proposed in the research that was made. And also, with the IRR value that was 31.8%, is higher than the expected one that was just 20% for the project. So it can be concluded that the project is viable since it will have a profitability of 11.8% above the expected one. For the recommendations, when this idea and this project is implemented in the physical factory system, the supervisor must verify continuously the performance of this implementation for the conveyor and the robotic arm to see if there's problems or if they are working fine. Also, we recommend the addition of more machine or different schedule that can help to improve even more the production of the company. Thank you.